we should know what is tubular function. So as you all know, the nephron, which is made up of the PCT and DCT, where DCT and CT plays a major role in water reabsorption. Most of the constituents are reabsorbed, 80 to 85% are reabsorbed in proximal tubule. So the three concepts or three processes in the mechanism of urine formation are GFR, which was discussed earlier, with Starling forces and how is it measured with inulin. Next we go on to what is tubular reabsorption and tubular secretion. Hydrogen and potassium are the only one which is secreted. So when the blood is filtered into across the Bowman's large volume of protein-free plasma. They are salty, sweet and sour. So as plasma because it is same as plasma. So this is how when there is a filtration taking place, protein is not filtered. It comes to the proximal cannulated tubule where maximum reabsorption takes place. Thus it flows into the descending limb and ascending limb along with the loop. So because of the osmosis or osmotic gradient, water is reabsorbed. The medulla has hyperosmolality. Then as it ascends upwards in the distal cannulated tubule, water is reabsorbed and also in the collecting duct. So there is a recirculation which enters the general circulation and water is conserved. So we need to know what is tubular reabsorption and secretion, tubular secretion. So whatever filtration, why is it called ultrafiltration? Because the filtration takes place at high pressure. During the process of filtration, a protein-free and cell-free filtrate is formed in the PCT. Hence it is ultrafiltration. The filtrate is called ultrafiltrate. The filtrate resembles plasma except for the absence of proteins. Reabsorption is from the tubular lumen into the peritubular capillaries. From the capillaries from the blood vessel into the tubular lumen is the secretion. So what are tubular function is filtered plus the tubular transfer is equal to the excretion. GFR is estimated with inulin. So plasma where example is more. If it is less, it is para-aminohypuric acid. Effects of sodium reabsorption and obligatory reabsorption of water, which happens in proximal cannulated tubule. Whereas facultative is in the DCT, which is because of the presence of aquaporins, which are the water channels. It creates an electrical gradient so whenever sodium is reabsorbed, along with sodium, water is reabsorbed because of the osmotic gradient, and this is called as obligatory reabsorption of water, which is a secondary active transport. So reabsorption is from the tubular lumen into the peritubular capillary, whereas this is how along with sodium, when there is more sodium, there is water reabsorbed. Sodium enters cell through the open channels, moving down its electrochemical gradient. So sodium is pumped out of the basolateral side because of the presence of sodium potassium ATPase pump. And sodium is high in the lumen. Sodium moves along with glucose. Glucose and sodium are reabsorbed, and thereby the sodium reabsorption takes place. Along with sodium, whenever glucose is reabsorbed, there is a reabsorption of the sodium and potassium exchange, which is a counter transport which happens in the capillary. So most of the reabsorption is in the proximal cannulated tubule. So glucoreabsorption is all the glucose that is filtered gets reabsorbed by the co-transport or secondary active transport with sodium ions. Energy for transport is provided by sodium potassium ATPase pump. The renal threshold for glucose is the concentration of glucose in the blood above which it starts appearing. Normally it's around 180 mg per deciliter. The tubular maximum for glucose, it is the maximum capacity of the nephrons to reabsorb glucose from the filtrate in an ideal condition. It ranges from 325 in females and 375 in males. So what is it? It is the highest concentration of substance present in filtrate beyond which substance begins to appear in urine due to saturation of the transport mechanism. TMG for men is 375. It is the renal threshold is 200 in arterial, whereas in venous it's 180 instead of 300 due to splay. So filtered minus reabsorbed is equal to. So what is splay? Although the maximum capacity of reabsorption of glucose is reported to be 325 to 375 milligram per deciliter, the actual reabsorption is far below the expected level. This deviation of actual absorption compared to the maximum capacity is called splay. What is it? So there is a deviation. You can see in the graph the rounded curve. The ideal is it has to be 325 to 375, but only the actual reabsorption is far below the expected level. This deviation of this variation is seen because why is this play? All the nephrons do not have the same capacity of reabsorption as the ideal nephron, and all the nephrons are not active and absorbing to their maximum at any given point of time. This is resulting in cause for splay. So for the regulation of GFR, we have tubular-glomerular feedback, where when the pressure decreases, the glomerular hydrostatic pressure decreases, which in turn decreases the GFR, and the sodium sensor, macular tensor senses the sodium chloride level, causing the release of renin from G cells, which forms the angiotensin II, and the afferent arterial resistance decreases, the glomerular filtration increases, and the afferent arterial resistance increases. So glomerular tubular balance is increased, GFR causes increase in reabsorption of water, maybe due to the increase of colloidal osmotic pressure in the peritubular capillary network. So one among the thing is Fanconi syndrome, where there is metabolic acidosis, glycosuria, aminoaciduria, and phosphaturia. This is the facultative reabsorption which happens in the distal convoluted tubule, where there is water reabsorbed in the presence of aqueous channels. So when there is osmotic gradient created along with sodium, water is reabsorbed in facultative reabsorption, which takes place in the proximal convoluted tube. There is also atrial natriuretic peptide and ADH. ADH increases urine output, whereas atrial natriuretic peptide decreases it.